Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab. And if you scroll down in the search question number 55, hit enter. So there is a question, jump game. It's come under the medium category. So let's click on it. So let's read the question. So you are given an integer array num. So some integer array is given. So if you see the function definition on the right hand side, so the input is nums and which is the array and which contains the integers. You are initially positioned at the array's first index. So you will add the first index, okay? And each element in the array represent your maximum jump length at that position, okay? Return true if you can reach the last index or false otherwise. So what basically they said is, so there is some array 2, 3, 1, 1, 4 which is given, okay? But what does, and you are at the first index. First index means you are at the zero index, or you can say you are at the first position, okay? And you need to reach till last position. Last position means like the end of the array, right? So you need to reach the last position. But how you are going to reach? Uh, okay, first thing is that we need to return true if we are able to reach at the last index. Otherwise, we need to return false. But what is the method to reach at the last index? So they said each element in the array. So each element in the array represent your maximum jump. So to go from first index to last index, you have to jump. You have to jump. So how long you can jump? Is it like just one index, two index, three index, four index, 10 index? How long you can jump? So basically, if you are on the first index, so the number is two. So it means maximum you can do two jumps. That is the maximum, but it's up to you whether you want to take one jump or two jump, but you can't take three jump if you are on the first index, right? So similarly, okay, let's go to the whiteboard to understand that. So let's pause. So let me take the pencil. So if you are on the first position, so in starting, you are at here, right? So here from the two, you can take either one jump. So one jump, if you take one jump, you will reach here, or either you can take two jumps. So if you take two jump, you will be here. All right. But you can take maximum two jumps. All right. So because the each element in the array represent your maximum jump length. Right. So if you are at position three, so you can take either one jump, you can take either two jump, or you can take either three jump. So you can take either one jump, you can take either two jump, or you can take either three jump. Right? If you are at index one, you can take one jump. If you are index one, you can take one jump. All right. So we need to find like, is there a way can we reach at the last index? So if you figure it out, let's we are on the two, right? If we are on the two, we take two jump. Let's suppose so one, two. So we are at here. So we reach here. So now we can take maximum one jump because the number is one. So we will here. Now we can take maximum one jump. So we will be here. So at the end, we reach four. All right. We are reach four. So we are going to return true. But we take directly two jump, but it could be one. All right. So if we do using taken each and every possibility, then it will be very lengthy. Okay, let's look at the second example. So it said like maximum you can take three jump. So 1 minute. It says maximum you can take three jump. So we are at, so 1 minute. So we are at three. So either we can go here, either we can go here, or either we can go here, right? So maximum three jumps. So if we take three jumps, so then we are at zero. From zero we can't take. If we take two jumps, if then we are at one, so then from one we can take here, then again we are zero, then we can't go further. If we take one jump only, then we are at index two, and from index two either we can take one jump or either we can take two jumps. All right. So if we take one jump, then we are one, then we are again zero. If we take two jump, then we are at zero. So in any case, we can't reach at the last index. So that's why we need to return the false. All right. So we need to return false. Right. So how we are going to approach this problem? So if you just look at this question, it looks maybe very complicated, right? It looks very complicated because it says like how we are going to know whether we will take one jump, two jump, three jump, and like this number could be anything. So if you look at the constraints, so let's scroll down. So this a number of i's could be 10 to power 5. So this could be 10 to power 5. So does I take 10 to power 5 combinations? No, absolutely not. All right. Because if you take 10 to power 5 combination, then it will be very, very lengthy process, right? So how we are going to solve this question? So just keep in mind where we need to reach, where we need to reach. We need to where is our target? All right. So where is our target? Like we need to try as far as possible. So in this case, our target is index 4. In this case, our target is index 4, right? So what we are going to do, we are going to scan each and every element, and we are going to know, okay, if we are at index 0, maximum where I can reach, maximum where I can reach. So so in starting, we will take a maximum reach, or you can say reachable is 0. So in starting it's 0, right? And we want to convert 0 to 4, right? But can we convert 0 to 4? Like, because initially it's at 0, because it says initially we are at the 0 index, and we want, if if anyhow we can make 0 to 4, then we can return true, right? So how we are going to do? So what we are going to do is, so 1 minute. So what we are going to do is, yeah. So what we are going to do is, so if you are at 0, if you are at 2 index, sorry, not 2 index, if you are at here, because you are starting here, so maximum where you can reach, so maximum you can jump 2 step, right? So you will reach at the position number 2. You will reach at the position number 2. So how you are going to calculate? So current index 0 and the number 2. So it is going to reach at the 2 index. So maximum you can reach at 2. So now, if you are at the 0 index, maximum you can reach 2. So current maximum, current current reachable is 0. So okay, now we know, 1 second, current reachable is 0. So we know 2 is greater than 0, so let's update, right? Because we already reached 2. Okay, so now let's go to the next element, 3, right? If we add 3, maximum where we can reach, maximum. So 1 plus 3, maximum we can reach at 4, right? Because if you take 3 jump, then how we are going to know for fourth index? How we are going to know fourth index? Because this current index and the number of jump it could take. So currently it's one position. If we take 3 jumps, then it will be 4. 3 plus 1, 4. So now if you see here, so what is, sorry. So now we are at the fourth. So is 4 is greater than 2? Yes, 4 is greater than 2. Now we will write here 4, because our purpose is to go as far as possible, as far as possible. So now we already reached here, so you don't need to even check for the further elements. Okay, so let's try this one, where we are going to return false. Okay, so initially reachable is 0, because we are at index 3. Okay, from index 3, from index 0, where you can reach maximum, where we can go maximum. Okay, so currently you are at 0, and I want to convert this to 4, because if anyhow I can reach to till 4, it means I will go, I reached the end index. So I am currently at 0 index. So from 0th index, maximum where I can jump, maximum. So 0 plus 3, 3. So maximum I can jump here, right? So is 3 is greater than 0? Yes, 3 is greater than 0. So I put 3 here, right? So I reached 3, which is perfectly fine. Now I come to the next index. So now I am at the first index. Okay, maximum where I can reach, maximum. So 2 plus 1, 3. So maximum I can reach 3. Okay, is 3 is greater than 3? No, or same. So I'm not going to update 3, because maximum is still 3. Okay, if I at 1, so if I at index 2, maximum where I can reach, 2 plus 1, 3. So again I can reach only third index. So is 3 is greater than 3? Like no, so maximum reachable is 3. Okay, now I am at the 0, a third index, because we have to scan each and every element. If I have 3, now we are 0. So maximum where I can reach, 3 plus 0, 3. So still it's 3. Okay, now I am at fourth index. So now our maximum is behind, and our current position is this. All right. So which is not possible. So which is not possible. So in this case, when our ith index go far behind than the maximum, because it means we can't even reach maximum. So in this case, we are going to return false. So basically, what we have to do is for each and every index, we need to scan, and for each and every index, we need to find, can we reach maximum? If we can reach like last index, then it's fine. So how we are going to approach this? So we need to take one variable reachable. Reachable is equal to zero. Initially it's zero, right? And we need to scan all elements, and we need this index number as well, and we need number. So better we can use enumerate function. So for I num in enumerate nums, because it is going to give me the ith index, and it going to give me the num as well. Okay. Now if I add the like zeroth index, so zeroth index maximum where I can reach. So like I need to update the reachable. And how? So so in initial in initial it's zero. In initial it's zero. So now I need to update the reachable, but how I'm going to reach update the reachable? So I need to update the reachable is equal to max of reachable, current reachable, which is zero, plus I plus 2, I plus num. So it means I plus num. I is the index, num is the number. So whatever is the maximum, it means like I can reach uh, uh, like uh, uh, I can update my reachable. If it is smaller, then the reachable will be the previous element. Or if you want to just put if else condition, that is also fine. If, otherwise, you can just use the maximum function. Okay. Now, so I is zero. I is zero. Okay. So I updated my reachable. So my reachable is now two. Right. So it's now two. Right. So now I is like 1. So my reachable is 3 plus 1, 4. So it is greater than 2. So for the maximum is 4. Right. So as soon as we are finding the reachable, we will check if reachable is equal to, so let's take n is equal to length of nums. So if reachable is equal to n minus 1, because we need to reach at the last index. If reachable is equal to n minus 1, so now reachable is equal to 4. Right? So reachable is equal to n minus 1, then we are going to return true. Right? So that we can skip all these array, and we can save our time. So we are going to return true. Okay, so this is perfectly fine. But what about this case? What about this case? So there is a one condition when ith index ith index is greater than the reachable. So if I is greater than the reachable, then we need to return false. It means we can't if ith index is greater than the reachable, like in this case, if we are on the 0, so reachable is 3. So we update 3. Now we are on the first index, so still reachable is 3. If we are on the second index, still reachable is 3. 2 plus 1, 3. If we are on the third index, still reachable is 3. Now we are on the fourth index. So I is greater than the reachable, right? So I is greater than the reachable. Now we need to return false, right? And at the end, we need to return true. If you run it, so sample KC has been accepted. Try to submit it. So that's done, because we beat 84.28% of the user, and we beat 68.25% of the memory. Even like you can skip this block as well. All right. So if reachable is equal to n minus 1, you can skip this. Why I put this block? Because so that we can skip all these further. If as soon as from any index we are able to reach from any index, if we are able to reach last index, so better check the if condition. All right. So we are saving some memory or some time as well. Okay, so that's it. By looking at the question, it looks complicated, but if you go through this uh, explanation, then you seems like it's very easy. Because what is our goal? Our goal is to reach at the last index. So I am first index, okay, where maximum I can, if I am the second index, where maximum I can reach, if I the second index, where maximum I can reach, if I the third index, where maximum I can reach, and you need to update the reachable. As soon as you reach the last index, return true. That's it. Right. So that's it. We already submitted this and it ran fine. So that's the end of the video. Thank you.